All right, so looking at lesson 1 here, we're just going to review some basic stuff you've talked about in other years in science, I'm sure. Some of it might be new, but we're going to start something that's definitely a review. So science is the ability to solve problems using data from experimentation. So the scientific method is a process that's used to solve a natural problem. Basically, you've learned these steps of scientific many times before. You essentially observe a problem, write a hypothesis, experiment, and then kind of see what your results give you and move forward from there. One thing I want to point out, though, the scientific method makes it seem very rigid, that you have to do those particular steps in that particular order. I want you to know that it's more of like a guide. So these all things happen, but they might not happen in that order, and it might be repeated and so forth. But when we look at this, one thing I want to make sure you know, observations are an important part of collecting data. They can be either qualitative or quantitative. And there's a difference here. So quantitative are going to be observations containing numbers, so numerical. I like to think of that because there's this N in quantitative, so there's numbers, okay? And qualitative would be things like observations with the senses. So think, for example, of things like what color is it? What do you see? What does it smell like? Is it hot? Those kinds of things. All right, so accuracy and precision are going to be important too. So accuracy is basically how close your value is according to the standard, and precision is how close are they to one another. So you can have data that's precise but not accurate, precise and accurate, neither precise nor accurate, or accurate but not precise. So basically any combination of them. So if we look at this picture here, I like to think about it the best relating to this target example here. So in terms of accuracy, when you throw a dart, you're looking for hitting that center target there, okay? So just off of that fact, if we're trying to hit the center target and I'm looking at the darts, I'm going to say this one is not accurate. It's not close to the bullseye here. This one would not be accurate either. But I would say this one is accurate. It's pretty close to the bullseye. Okay? Now, precision is how close they are to each other. So these are all pretty spread out. This person's not consistent, so I would say they're not precise. This one, though, they are pretty close to each other. It doesn't matter that they're not on the bullseye, but they are close to each other, so I would say these precise here. Let me rewrite that, so precise. And then this one, I would say it's both accurate and precise. Okay, it's very close to the bullseye, and they're all close to each other. You can think about this in terms of data too. So if we look at these, if we know the actual boiling point of methanol is 64.7, and we want to try to figure out if these are accurate, precise, or a combination of them. So if we look at experiment 1, so these are kind of all sorts of spread out, and there's not really close to 64 on any of them. So I would say that this one is neither accurate or precise. This one here, if we're shooting for 64.7, these are all right around there. So I would say this one's both because they're close to each other as well. This one here would just be precise. That's because they're close to each other, but they're not really anywhere close to the 64. Metric prefixes, hopefully you remember these. So I know you might have heard the acronym before. King Henry died, unfortunately, drinking chocolate milk. You can use that here as well, but I also have a table that kind of tells you how they are related to each other. All right, so when we talk about using calculations and using units particularly, we're just going to kind of go through some examples using this density equation since you've been used to seeing this one for a while. So you're going to need to be able to solve for different variables and to plug things in when need be. So if we look at this first one here, calculate the density of a solid with a mass of 3.4 grams and a volume of 1.23 liters. Make sure you keep your units. That's the whole point of doing this. So we're going to do a lot of calculations this year, so we're going to make sure we know how to do these with units. So I'm just going to rewrite the equation here. We have our mass in the problem as 3.4 grams. Our volume is 1.23 milliliters. So if we go ahead and divide these out, we're looking at about 2.76 grams per milliliter. Okay, notice my units throughout the whole problem. Okay. All right, so if we go ahead and do the second one, this is a little different. We need to calculate the mass of an object if the density is this and the volume is that. So we need to solve for a different variable. Since mass is on the top, to get it alone, I'd multiply both sides by V here. So if I do that, I'm going to get mass is equal to density times volume. All right, so if I go ahead and plug things in now, we're looking at 0.778 grams per milliliter. and we're going to multiply that by 13.2 milliliters. We're going to get a mass of 10.27 grams. So go ahead and try number 3 and make sure you can solve for the only other variable we haven't done yet, which is volume, and we're going to keep working through calculations all year.